Are there extra dimensions? Hello, curious minds and reality explorers. Welcome to Blissful Gaming Paradise. In this podcast, we dive deep into the mysteries of the universe. I'm your host, Dev, and today we're embarking on a mind-bending journey into a realm that challenges our very perception of reality. Have you ever had the feeling that there's more to our world than what meets the eye? That perhaps just beyond our reach, there are aspects of existence we can't quite grasp? Well, hold on to your hats, because today we're exploring a concept that might just blow your mind. Extra dimensions. Now, I know what you're thinking. Extra dimensions? Isn't that just science fiction? Well, my friends, the line between science fiction and science fact is often blurrier than we might think. Today, we're going to explore the fascinating world of extra dimensions, what they are, why scientists think they might exist, and what their existence could mean for our understanding of the universe. In this podcast, we'll be covering quite a bit of ground. We'll start by explaining what exactly we mean by extra dimensions, and how they differ from the dimensions we're familiar with. Then, we'll dive into the evidence that suggests these extra dimensions might actually exist. We'll explore some mind-bending theories like string theory and M theory, and we'll even touch on the philosophical implications of a multidimensional universe. So, whether you're a physics buff, a sci-fi enthusiast, or just someone who loves to ponder the big questions of existence, this episode is for you. Are you ready to stretch your mind and explore the edges of reality? Then let's dive in. What are extra dimensions? Alright, let's start with the basics. When we talk about dimensions, what exactly do we mean? In our everyday experience, we're familiar with three spatial dimensions: length, width, and height. These are the dimensions that allow us to describe the position of any object in space. We can move forward and backward, left and right, up and down. Simple, right? But here's where things get interesting. In physics, we actually consider time as a fourth dimension. This gives us the concept of space-time, where every event can be described not just by where it happens, but also when it happens. This four-dimensional space-time is the playground of Einstein's theory of relativity. Now, when we talk about extra dimensions, we're going beyond these four dimensions of space-time. We're proposing the existence of additional spatial dimensions beyond the three we can directly observe. But wait, I hear you say, if these extra dimensions exist, why can't we see them? Excellent question. And to answer it, we need to use a bit of imagination. Imagine you're an ant living on the surface of a very long, very thin wire. From your perspective as an ant, you can only move in one dimension forward or backward along the wire. The wire itself has a second dimension, its thickness, but it's so small compared to the length of the wire that you, as an ant, can't perceive it. Now, let's scale that up. Imagine our entire universe is like that wire, but instead of being one-dimensional, it's three-dimensional. Just like the ant can't perceive the thickness of the wire, we can't perceive these extra dimensions because they're incredibly small and curled up. This idea of curled-up dimensions comes from a branch of physics called string theory. According to string theory, our universe might actually have 10 or even 11 dimensions, but most of these dimensions are curled up so tightly that we can't detect them in our everyday experience. Think of it like a garden hose. From a distance, a garden hose looks like a one-dimensional line. But if you get up close, you can see that it actually has a second dimension, its circular cross-section. The extra dimensions in string theory are thought to be curled up in a similar way, but on an incredibly tiny scale, we're talking smaller than an atom. Now, you might be wondering, why would physicists even propose such a wild idea? What's wrong with the dimensions we already know about? Well, my curious friends, that brings us to one of the biggest challenges in modern physics: the quest for a theory of everything. You see, we currently have two incredibly successful theories in physics: general relativity, which describes gravity and the behavior of very large things like planets and galaxies, and quantum mechanics, which describes the behavior of very small things like atoms and subatomic particles. The problem is, these two theories don't play well together. They work great in their own domains, but when we try to apply them both at the same time, like when we're dealing with black holes or the early universe, things start to break down. This is where extra dimensions come in. Theories that include extra dimensions, like string theory, offer a potential way to reconcile these two pillars of modern physics. They provide a framework where both gravity and quantum mechanics can be described in a single, unified theory. But here's the kicker. For these theories to work mathematically, they require the existence of these extra dimensions. It's not just a wild guess or a fun what-if scenario. These extra dimensions are a necessary component of the mathematical framework that could potentially explain everything in our universe. Now, I know what some of you might be thinking. This all sounds pretty far-fetched. Is there any actual evidence for these extra dimensions? Well, my friends, that's an excellent question. And it brings us to our next topic, the hunt for evidence of extra dimensions. Evidence for extra dimensions. Now, I want to be upfront with you. As of now, we don't have any direct, conclusive evidence for the existence of extra dimensions. If we did, it would be one of the biggest scientific discoveries in history. But what we do have is a growing body of indirect evidence and theoretical frameworks that suggest extra dimensions might be real. Let's start with one of the earliest theories to propose extra dimensions, the Kaluza-Klein theory. Picture this. It's the 1920s. Einstein has recently published his theory of general relativity, which describes gravity as a curvature of spacetime. But there's another fundamental force that doesn't fit into this framework, electromagnetism. Enter Theodore Kaluza and Oscar Klein. These two physicists had a wild idea. What if we could unify gravity and electromagnetism by adding an extra dimension to Einstein's equations? Remarkably, when they did this, they found that Einstein's equations in 5 dimensions naturally give rise to both gravity and electromagnetism in 4 dimensions. It's as if electromagnetism is just gravity leaking in from an extra dimension. Now, the original Kaluza-Klein theory had some problems and isn't considered a complete description of reality. But it was a huge conceptual breakthrough. It showed that extra dimensions could potentially explain and unify different aspects of physics in a beautiful, elegant way. Fast forward to today, and we have more sophisticated theories that build on this idea, like string theory and M theory. These theories not only aim to unify gravity and electromagnetism, but all 4 fundamental forces of nature. But here's the catch. For these theories to work mathematically, they require the existence of extra dimensions. String theory, for example, proposes that the fundamental constituents of the universe are tiny, vibrating strings of energy. But for the math of string theory to work out, these strings need to vibrate in 10 or 11 dimensions. Now, you might be thinking, that's all well and good in theory, but is there any actual physical evidence for these extra dimensions? Well, my curious friends, that's where things get really interesting. While we can't directly observe these extra dimensions, remember our ant on a wire analogy. Scientists have been devising clever experiments to look for indirect signs of their existence. One approach is to look for anomalies in particle physics experiments. You see, if extra dimensions exist, they might affect the behavior of particles in subtle ways that we can detect. For example, some theories predict that gravity might be much stronger at very small distances due to effects from extra dimensions. Scientists have performed incredibly precise measurements of gravity at small scales to test this idea. So far, they haven't found any deviations from what we'd expect with just 3 spatial dimensions. But these experiments are ongoing and getting more precise all the time. Another line of evidence comes from the world of cosmology. Some theories suggest that extra dimensions might have effects on the large-scale structure of the universe or the cosmic microwave background radiation left over from the Big Bang. Scientists are scouring our observations of the cosmos for any signs that might point to the existence of extra dimensions. There's also the tantalizing possibility that extra dimensions could explain some of the mysteries of our universe, like dark matter and dark energy. Could these mysterious components of our universe be effects of matter and energy in extra dimensions? Now, I want to emphasize again that none of this is conclusive proof of extra dimensions. Science is a process of gathering evidence, forming hypotheses, and testing them rigorously. The idea of extra dimensions is still very much in the hypothesis stage. But the fact that so many lines of theoretical and experimental work point in this direction is certainly intriguing. But let's take a step back for a moment. We've talked about what extra dimensions are and some of the evidence that suggests they might exist. But what if they do exist? What would that mean for our understanding of the universe and our place in it? Implications of extra dimensions. All right, folks, it's time to put on our imagination hats. We're about to venture into some truly mind-bending territory. If extra dimensions do exist, what could that mean for us and our understanding of the universe? Let's start with some of the more practical implications. One of the most exciting possibilities is that extra dimensions could potentially allow for faster-than-light travel. Now, I know what you're thinking. Faster-than-light travel? Isn't that impossible according to Einstein's theory of relativity? And you're right, in our familiar four-dimensional space-time, nothing can travel faster than light. But here's where extra dimensions get really interesting. Imagine our universe as a two-dimensional sheet of paper. If you want to get from one point to another, you have to travel along the surface of the paper. But what if you could fold the paper, bringing two distant points together, and then punch a hole through? This is essentially the idea behind wormholes, theoretical tunnels through space-time that could provide shortcuts between distant points in the universe. And while wormholes are possible in theory even in four-dimensional space-time, extra dimensions could make them much more plausible. In a universe with extra dimensions, what looks like a vast distance to us might actually be a short hop through an extra dimension. It's like how an ant walking along the surface of an apple might have to travel a long distance to get from one point to another, while a human could simply push a straw through the apple to connect those points directly. But the implications of extra dimensions go far beyond just potential sci-fi travel methods. They could fundamentally change our understanding of the nature of reality itself. For example, some theories suggest that our entire universe might be a three-dimensional brain, short for membrane, floating in a higher dimensional space. This idea, known as the brain world scenario, opens up mind-boggling possibilities. Could there be other universes out there, other three-dimensional brains floating in the same higher dimensional space? Could what we think of as fundamental particles actually be the endpoints of strings stretching through extra dimensions? Could the mysterious dark matter that seems to permeate our universe actually be ordinary matter in a parallel brain, invisible to us except through its gravitational effects? These ideas might sound like science fiction, but they're actually serious proposals being explored by theoretical physicists. And if true, they would completely revolutionize our understanding of the cosmos. But the implications of extra dimensions aren't just physical, they're philosophical too. The idea of extra dimensions challenges our very notion of what constitutes reality. Think about it. We tend to think of reality as what we can directly observe and interact with. But if extra dimensions exist, that means there's a whole aspect of reality that's hidden from our everyday experience. It's a humbling reminder of how limited our perception might be, and how much more there could be to the universe than what we can directly see or touch. It also raises fascinating questions about the nature of consciousness and our place in the universe. Could our consciousness somehow interact with these extra dimensions in ways we don't understand? Could some of the mysteries of human experience, things like intuition, creativity, or even spiritual experiences, be related to connections with extra dimensions? Now, I want to be clear. These are speculative ideas, not scientific theories. But they illustrate how the concept of extra dimensions doesn't just challenge our understanding of physics, it challenges our entire worldview. Of course, with all these exciting possibilities come significant challenges and limitations. Studying extra dimensions is incredibly difficult precisely because they're so hard to detect. If these extra dimensions exist, they're likely curled up at scales far smaller than we can directly probe with our current technology. We're talking about distances smaller than a proton. This makes directly detecting them extremely challenging. Moreover, many of the theories that propose extra dimensions, like string theory, make predictions that are currently beyond our ability to test experimentally. This has led to debates in the physics community about whether these theories are truly scientific if they can't be tested. There's also the challenge of mathematics. The mathematics used to describe extra dimensions is extremely complex and abstract. It's so challenging that even many physicists struggle to fully grasp all its implications. This can make it difficult to translate these mathematical models into testable predictions about the physical world. But here's the thing. Throughout the history of science, we've repeatedly discovered that the universe is stranger and more wonderful than we ever imagined. From the bizarre world of quantum mechanics to the mind-bending effects of relativity, reality has a way of surpassing even our wildest speculations. So while the challenges in studying extra dimensions are significant, they're not insurmountable. Scientists around the world are working tirelessly to devise new experiments, refine theories, and push the boundaries of our understanding. And who knows, perhaps someday we'll find conclusive evidence of these hidden dimensions. Or perhaps our search for extra dimensions will lead us to entirely new discoveries we can't even imagine yet. That's the beauty of science. It's an endless journey of discovery, always pushing us to look beyond what we think we know. As we near the end of our journey through the mind-bending world of extra dimensions, let's take a moment to recap what we've learned and reflect on what it all means. We started our exploration by defining what we mean by extra dimensions, additional spatial dimensions beyond the three we can directly observe, potentially curled up at microscopic scales. We learned about the theoretical frameworks that propose these extra dimensions, from the early Kaluza-Klein theory to modern string theory and M-theory. We discovered how these extra dimensions could potentially help unify our understanding of the fundamental forces of nature. We explored the ongoing search for evidence of extra dimensions, from particle physics experiments to cosmological observations. While we don't have conclusive proof yet, the hunt is on, and scientists are devising ever more ingenious ways to test these ideas. Finally, we delved into the implications of extra dimensions, from the potential for faster-than-light travel to profound questions about the nature of reality itself. So, what do we make of all this? Are there really extra dimensions out there, hidden aspects of reality just beyond our perception? The honest answer is we don't know yet. The idea of extra dimensions remains a hypothesis, an exciting possibility that we're still exploring. It might turn out to be true, or it might lead us to entirely new discoveries we can't even imagine yet. But here's what I find truly exciting. The very fact that we can ask these questions, that we can probe the fundamental nature of reality in this way, is amazing. It speaks to the incredible progress we've made in our understanding of the universe. Think about it. Just a few centuries ago, the idea that the Earth wasn't the center of the universe was considered radical. Now, we're contemplating the possibility of entire dimensions beyond our everyday experience. We're pushing the boundaries of what we know, venturing into realms that once belonged purely to the realm of imagination. And that's the beauty of science. It's not just about what we know, it's about what we don't know, and our relentless pursuit to understand more. Every question we answer leads to new questions, new mysteries to explore. The concept of extra dimensions, whether it turns out to be true or not, pushes us to think beyond our everyday experience, to imagine new possibilities, and to devise ingenious ways to test our ideas. So, what do you think? Does the idea of extra dimensions excite you? Confuse you? Maybe a little bit of both? That's okay. These are complex ideas that challenge our usual way of thinking about the world. But I hope this discussion has sparked your curiosity and maybe given you a new perspective on the nature of reality. Before we wrap up, I want to encourage you to keep exploring these ideas. If you're intrigued by what you've heard today, there are plenty of resources out there to learn more. Check out books on string theory or modern cosmology. Watch documentaries about the frontiers of physics. And don't be afraid to ask questions and challenge your own assumptions. Remember, every great scientific discovery started with someone asking a question that seemed impossible to answer. Who knows? Maybe your curiosity about extra dimensions will lead you to the next big breakthrough in physics. And for those of you who might be feeling a bit overwhelmed by all this talk of extra dimensions and complex physics, don't worry. You don't need to understand all the mathematical details to appreciate the wonder of these ideas. The important thing is to keep that sense of curiosity alive, to stay open to new possibilities, and to never stop asking questions about the world around us. After all, that's what science is all about, not just knowing, but wondering. Wondering about the nature of reality, about our place in the cosmos, about what else might be out there waiting to be discovered. So, the next time you look up at the stars, or ponder the mysteries of the quantum world, or even just go about your daily life, take a moment to consider, what if there's more to reality than what we can see? What if the universe is even stranger and more wonderful than we can imagine? These are the questions that drive science forward, that inspire us to keep exploring and discovering. And who knows, maybe someday we'll find those extra dimensions. Or maybe we'll discover something even more amazing. The only way to find out is to keep asking questions, keep exploring, and keep pushing the boundaries of our understanding. Thank you for joining me on this mind-bending journey through the concept of extra dimensions. I'm Dev, and this is Blissful Gaming Paradise, signing off for today. Until next time, keep wondering, keep questioning, and keep exploring the amazing universe we live in.